subtracting fractions is a piece of cake once we get the idea down. Now let's say that we have, for our first problem, the fraction 3/4, and we want to subtract from that fraction another fraction, 1/2. So we want to start out with 3/4, that's a larger fraction, and we want to take away this much, all right? Now we look at our denominators. We have a 4 and we have a 2. How do we get a common denominator? Well, the easiest way is just to manipulate this fraction, because I have a 2, 2 times 2 is 4, and then I can make it match this one. So instead of solving this problem, we're going to solve a related problem, a problem similar to it. So let's go ahead and say and figure that out. 3/4 minus the 1/2. How are we going to change that 1/2? Well, we'll just multiply the bottom by 2 and also multiply the top by 2. So what we'll have is 3/4 minus 1 times 2 is 2, and 2 times 2 is 4. Now what we're basically saying is that this fraction 3/4 remained unchanged from the problem, but the fraction 1/2 is exactly the same as the fraction 2/4, and so we haven't really changed anything, even though it looks a little different. So let's see what this looks like. We have 3/4, that's 1/4, 2/4, and then we have 3/4 of a pizza. So I'll put that under this guy right here. And we're going to start with this much, but we're going to take away half of a pizza. So this is half. So we're going to take away half there. Now, we're saying that this we're going to leave unchanged over here. So let me go ahead and just put this down. 1/4, 2/4, 3/4. We'll just kind of leave it in the same way. But we're saying that the 1/2 can be represented by 1/4, 2/4. Now make sure, first of all, you understand that all this is true, right? Because the 1/2 is exactly the same as 2/4. It's the same amount of stuff. So solving this problem, starting with this and taking away this, is the same thing as starting with this one and taking away this one. Now it might be a little bit easier if I rotate this way, and I'll do the same thing right here, just to kind of have everything lined up. If I start with this much, and I'm taking away this much, that means I'm going to be removing all of this. This is telling us how much we're taking away. I'm only going to have 1/4 left over. So let's see if that's what we get when we actually finish solving the problem. So if we start at 3/4 and take away 2/4, the denominator is the same. So the denominator just stays there. But notice that instead of adding the numerators, we have to subtract them. So on the top we have 3 minus 2, and 3 minus 2 is 1/4. Now we cannot simplify this any further because we can't divide top and bottom by anything to make it simpler. So what we're saying is that the answer to this problem is just simply 1/4. And the reason it's 1/4 is because if you start with this much pizza and you're taking away 2 slices, this tells me how much I'm taking away. I remove it. What do I have left? 1/4, and that's why it is the answer. All right, now let's go back to the original problem, this. If we start with 3/4 of a pizza and we take 1/2 away, it means we have to take this much away, right? Because this is half. What do we have left? 1/4. So it's all the same. With models, it's very easy to see what to do. We're only going to use them in the beginning, but ultimately we're going to strip away all the pictures, and what you'll need to do is just get that common denominator, subtract the numerators, and get the final answer. So let's use one more example with pictures, and then we'll take the training wheels off. Let's say we have the problem 5/6, and we're going to subtract from that the fraction 1/3. So same kind of thing. We have a 6 and a 3. We need a common denominator to subtract them. I have a 6 and a 3. The easiest way to do it is just to change this fraction. Change it to a 6, because 3 times 2 is 6. I can change that. So what will I do? I will rewrite the problem. The 5/6, I'm actually going to leave alone. 5/6. And the 1/3, I'll rewrite it here. And how do I change that denominator? Well, I'll multiply the bottom by 2, and I'll multiply the top by 2. So what will I get at the end of the day for the new fractions I'll actually solve? The 5/6 will remain unchanged. 1 times 2 is, don't forget the subtraction sign, is 2. And 3 times 2 is 6. Now what we're saying is that this fraction remained unchanged, and this fraction is represents the same exact thing as this. Now let's see if that actually makes sense before we finish solving the problem. Actually, let's go ahead and solve the problem first. That changed my mind. What we have here is a denominator of 6. I'll skip down here to put the denominator of 6. The numerator is 5, but we have a minus sign. Subtract the numerators. 5 minus 2. So 5 minus 2 is what? 3 on the top and 6 on the bottom. Now, 3/6. This is the final answer. However, I can simplify it because I can divide top and bottom by 3. We always check to see if we can simplify. So let's simplify this. 3/6. How do we simplify it? We said we can divide the top of this fraction by 3 and the bottom by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. And this is fully simplified. So what we're thinking is that when we take this fraction and subtract this one, it's impossible for me to visualize, but when you actually take it away, you still have half a pizza left. Now let's see if this actually does make any sense. So here we have 1/5, then 2/5, then 3/5, I guess I'll push it over here, and then 4/5 right here, and then 5/5 right here. So this is the initial amount of pizza that we started with right here, 5/6. Now we're taking away 1/3, which is this amount. So we're starting with this and we're actually subtracting this away. Now, we said that the 5/6 is going to remain unchanged. So I'll go ahead and just put it over there again, 1/6, 2/6, 3/6, and then we have 4/6, and then we have 5/6. So this just remains unchanged, but the 1/3 we're actually saying is the same as 2/6, 1/6, 2/6. Okay, so let's see if that makes sense. 1/3, is it equivalent to 2/6? And it is. It's the same thing. So solving this problem is exactly the same as solving this problem. Now what do? You start with this amount of pizza, and you take these slices away, which is 2 slices. What happens if I take 2 slices away? I have half a pizza left. I mean, yeah, it's 3/6, 1, 2, 3, 6, but that's the same as 1/2 because when I take those 2 slices away, this is telling me what slices to take away. I have half left over. So if you wanted to be really clear about it, you would say the answer was 1, 2, 3/6. That's what we get right here. I'll put it like this. And that's exactly the same thing as 1/2. So that's what we want to understand. We want to say, we start with this, we take this away, we rewrite them in a common denominator. This tells me that I can just remove these 2 slices. I have half, or 3/6 left over, which is the same as 1/2. And then finally now, we can go over here to our original problem, 5/6 minus 1/3. What if we know that these are equal? It's telling me to take this much away. So if I just take these away, which is equivalent, notice I have a half left over. That's what we're trying to figure out. So I think that's all we're going to do with the pictures. The pictures are great, but we have to take the training wheels off eventually. All right, so let's just move right along to the next problem. Let's say we have 3/4, and we'll subtract from that 1/8. No pictures. What do? We have a denominator of 4 and 8. The easiest way is just to turn this into an 8. So I'll change this 3/4, and the 1/8 I'm just going to leave alone. I'm not going to touch that, but I'm going to change this 3/4 by what? Multiplying by 2 on the bottom and 2 on the top. What does that actually do? Well, it's going to be 3 times 2 is 6, and 4 times 2 is 8. Subtract 1/8. Now I have an 8 on the bottom, which means, as a common denominator, which means that 8 is the common denominator. 6 minus 1. 6 minus 1 is what? 5/8. And I can't simplify this anymore. I can't divide top and bottom by anything else to make it any simpler. So if I built this fraction and I built this fraction, took it away, then I would be able to express what's left over in terms of 5/8 of a pizza. Cut a pizza into 8 pieces, take away, or have 5 of those. That would be the final answer. All right. Getting pretty close to halfway here. Let's take a look at 9/10, and we'll subtract away from that 2/5. So again, 10 and 5. I can turn this 5 into a 10 and it'll match the denominator. So that's what I'm going to do. Keep the 9/10 first, and then the 2/5 needs to be rewritten in a common denominator. So I'll just multiply it by 2, multiply it by 2. What does that actually do? The 9/10 will stay, but then I have 2 times 2 is 4, and 5 times 2 is 10. So this problem is the same as this problem, and I see that the denominator is a 10. So that will be my answer. And then 9 minus 4 goes in the numerator. 9 minus 4. 9 minus 4 is 5/10. Now this is the answer, but I can simplify this because I can divide top and bottom by 5. They're both divisible by 5. So divide the top by 5. Divide the bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2, and after all that work, we figure out that the answer, when we start with this and take this away, is half of a pizza. And that's what that means, or half of a candy bar, or whatever we're talking about. All right, so we're done with the halfway mark. A little faster without the pictures, but I do like doing the pictures in the beginning because it really helps ground us so we have a good image in our head of what's going on. Let's take a look at 1/2, and we'll subtract away from that 1/6. So we have a 2 and a 6. The easiest way is just to change this into a 6 by what? Multiply by 3. 2 times 3 is 6. So I'll rewrite this, and I'll subtract away the 1/6. I'm not going to change that at all. I'll multiply here by 3, multiply here by 3. And what I will get is 1 times 3 is 3, and 2 times 3 is 6. And I'll subtract away 1/6. The denominator is a 6. It stays in the answer. And then 3 minus 1. 3 minus 1 in the numerator. 3 minus 1 is 2, 6. Now this is the answer, but I can simplify this. They're both even numbers. So I'll divide the top and bottom by 2. And the bottom again by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So the answer to all of this is 1/3, and that's the final answer. Notice how once we get in the groove, it's just very, very much the same thing over and over again. We just get a lot of practice with it, and so that's what we're doing here. Let's take a look at 7/8, and we'll subtract from that 1/2. I have an 8 and I have a 2. Easiest way to make these the same is just to multiply this by 4. 2 times 4 is 8, and then it will match. So I'll keep the 7/8, and then I will rewrite the 1/2 by multiplying by 4, multiply by 4. And then I'll have 7/8 minus 1 times 4 is 4, and 2 times 4 is 8. This is the problem I will solve. I have a denominator that's common of an 8, and then 7 minus 4 goes in the numerator. What is 7 minus 4 anyway? It's 3, and then 8 on the bottom. I can't simplify that anymore. I cannot divide top and bottom to make that any simpler, so I just leave it as 3/8, and that's the final answer. All right, we only have 2 more problems. Stick with me, we're almost done. 2 more. Let's take a look at 5/9 minus 1/3. I have a 9 and a 3. Easiest way is to change this to a 9. 3 times 3 is 9, so I will leave the 5/9 alone. But I will change this 1/3. And I will change the 1/3 by multiplying the bottom by 3 and the top by 3. Then the 5/9 will come along for the ride. And then here, 1 times 3 is 3, and 3 times 3 is 9. This is the problem I will solve. The denominator is a 9, so that goes in the answer. 5 minus 3 goes in the numerator. What is 5 minus 3? It is 2. And then I have a 9, and this is the final answer. I can't simplify that any further. I can't divide top and bottom by anything to make that simpler, so I'm actually done. And here's our very last problem. Let's take a look at 5/9, and we'll subtract 5/18. Looks very hard, right? Because you have a big old 18 here, but it's not. Because all I have to do is say 9 times 2 is 18. I can turn this into an 18. So I'll rewrite the 5/9. And I'll leave this one, I'll just leave it alone. I don't need to change it because I'm going for a denominator of 18. Multiply this times 2 to give 18. Multiply that by 2. And what do we actually have here? We say 5 times 2 is 10, and then 9 times 2 is 18, and then 5/18. I have a denominator of 18, so then I write that in the answer. 10 minus 5 is 5. And so the answer is 5/18. I cannot simplify that any further, so I'm done with the problem. So you can see how this works out. The problem is very hard. It's basically impossible for me to look at these problems and just know, like, oh yeah, this minus this is this. I mean, I just can't do it. Like, if you can do it, great. You are way, way better at this than I am. You have to write everything down. Please don't skip steps. You're just going to make yourself frustrated because you'll make an error eventually. Write the original problem. Rewrite the fractions. And then, of course, carry out the multiplication to get the new fractions. Then carry the denominator, subtract the numerators, then check and see if you can simplify. Sometimes we did have to simplify, like here. We got an answer of this and we simplified to get the real answer. Sometimes you don't have to simplify. Just check every time to see if the answer is simple. Now, I'd like you to solve all of these yourself. Follow me on to part 2. We're going to do more practice with subtracting fractions. These problems, we only had to change one of the fractions. In the next lesson, we'll have to change both fractions in order to get a common denominator. Learn anything at mathandscience.com.